here's a function y equals to fx, where I'm not going to give you the explicit formula, but I'm just going to say the graph looks like here's 1, here's 3, and here's 5, okay? And let's say the graph goes up. When it hits 1, it's gonna go briefly become 0. It's gonna briefly halt, but then increasing again. Right? And at 3 it peaks, and at 5 it bottoms out and goes up again. If this is given, the question is, what is the graph of y equals to f prime of x? Graph. That's the question. In this case, how can we use that observation that if the function is increasing, f prime is positive, if the function is decreasing, f prime is negative? How can we use that? So let's try to use that. Okay, before 1, is the function increasing?
Yes.
Yes, increasing, right? So before 1, I know it's positive. Just put a plus there before even drawing it. Okay? It's a good way to remember what to do, to say plus. Between 1 and 3, is the function increasing?
Yes.
Yes, it is, right? So 1 and 3 is still increasing, right? How about 3 and 5? It's decreasing, so the derivative is negative, okay? If the function is decreasing, the derivative is negative. So what do I write? I can put a minus here. Or just to stress that it has to be under, let's just put it here. Okay? So pluses, you put plus on above the x-axis. For minuses, you put below the x-axis. Because if the value of the function is negative, that means it's below the x-axis. Right? And after 5, what's happening? It's plus. Now, you should also figure out the places where the graph has horizontal tangents. I said that it's here. It's briefly 0, only at this point, okay? And here, and here. At these 3 points, f prime should be what? 0. So at 1 and 3 and 5, the graph of the f prime should be touching the x-axis. It should pass through these points. All right, now let's think a little bit more. Here, the slope of the tangent is quite steep, and gradually the slope of the tangent goes down. Right? I mean, see, this is quite steep, and the slope is very, very high, and this will be a slope that's gentle. It's a gentle slope, and the derivative is pretty small. So you can see that as you go from left to right, the derivative starts from some very high value and it goes down to 0 at 1, right? So you see that the graph should be like coming down from some high value and it should hit 0. But then, if you look at the slope decreases, right? Then falls down back to 0. So it goes like that. So the slope is gentle here, becomes steep, and then becomes a gentle slope again. Okay, so you get something like this. Okay. Goes up, the value of the slope goes up and comes down. Okay, now what? Between 3 to 5, it's negative. As that's why you want to write this down. If you see this minus sign, you know that the graph should be going in the negative domain. Okay, you don't draw here; it should be here. So the graph should go down and come back to 0. and then afterwards it's positive, and it should increase to infinity. So that's how you draw the graph of f prime when you're not given the explicit formula. If you love explicit formula so much, there is a way to do this using formulas. I mean, you can think of a polynomial that would hit these values, but trying to come up with the formula will be very hard. Okay. So just using the fact that the slope corresponds to the value of f prime, it's much easier when trying to draw the graph of f prime.